Hello everyone and welcome to our webinar. My name is Tarlan Süleymanov and I am co-chairman of Azerbaijan Science Association. Today's webinar is our 12th webinar and it will be about self-driving cars. Before I introduce our speaker, I would like to mention that you can post your questions in the comment section of this live stream, and I will try to ask posted questions from our speaker during the webinar. Now, I would like to give a short introduction about today's speaker. Professor Paul Newman is director of the Oxford Robotics Institute, and he's the BP Professor of Information Engineering at the University of Oxford. With over 20,000 citations, 200 papers, and fundamental contributions to robotics, he is the inventor of techniques that allow machines to know where they are, what surrounds them, and what they should do next. He was elected Fellow of the Royal Academy of Engineering and Fellow of IEEE in 2014 for his outstanding contributions to robot navigation. He served on the United Kingdom Department for Transport's Scientific Advisory Council, and he was an architect of the UK's robotics and autonomous systems strategy. He is co-founder and CTO of Oxbotica, which is one of the world's leading autonomous driving companies. He is a member of the UK Prime Minister's Councils for Science and Technology. And finally, the last important point, well, at least for me, he was my supervisor when I... Thank you, Paul, for accepting our invitation, and it's a great honor for us to have you here.
Well, thank you very much. It's really great to be here. And thank you, Tarlan, for a fantastic introduction and a fantastic PhD.
Oh, thank you very much. Usually we have a very broad audience from different backgrounds, and that's why at the beginning of the webinar, I would like to ask questions to cover some basic concepts about self-driving cars. So my first question will be, what are the self-driving cars and why do we need them?
Okay, so I think, well, let's start with what a self-driving vehicle is. So that's a vehicle that has no steering wheel. It might not even have any windows in it. And it's available to drive people or goods anywhere, any time of day, any weather. That's the ultimate, isn't it? So you might think that's like having a car that you buy now that can take you any place, any time, any weather, any condition. You never need to worry about it. But for me, self-driving vehicles are more than that. So I think about every kind of vehicle. So I think about vehicles that are in airports. I think about vehicles that are down mines. I think about vehicles that are in ports and warehouses. So for me, it's the same problem, because your self-driving vehicle has to answer, where am I? What's around me? What's going to happen next? And what should I do? Right? Now, if you can answer in software those questions, so use sensors, maybe they're cameras, lasers, radar, GPS, to answer the question, where are you in the world? And then figure out, well, what's the stuff around me? Like, is that a vehicle? Is that a car? Is it a person? Is it a horse? Is it something in a port that's going to move, part of a ship? You know what those things are. You could then say, well, I know where I am. I know what's around me. So now I can make a prediction about how those things are going to change. How are they going to move around me? So if I have that model now in my head, in my software, I can then make a plan about how to drive. And that plan is literally steering wheel, how much angle the wheels are at, and how fast you go for how long. And if you can make that go really fast and really reliable, then you can build yourself a self-driving vehicle. And why do we need them? Well, many accidents are caused by vehicles, and not just on the roads. When we get old, when we're very young, when we get ill, we can't drive. Humans make one kind of mistake again and again and again, and they lose concentration. We're very good at solving hard problems, but very bad at concentrating on simple problems all the time. So most accidents come from just humans just sort of getting distracted and looking around and something happens. There are other things. There are places where you want vehicles that are really challenging environments where it's not pleasant to work. So underground in some mines, very hard conditions, dark conditions in some warehouses, where we want to have more things moved safer and cheaper. So for me, that's a really big thing about self-driving vehicles. It's not just about self-driving cars.
So as we talk about why do we need them, so I would like to ask such a question. How will the autonomous cars change the world? And if they were around, how could they help us with tackling this pandemic?
Oh, okay. So I think about that a lot. That's a really good question. So one way they would be able to help is delivery. So if you think about people that are shielding or are elderly that really can't come into contact with anybody, if we were able to get groceries and milk and drugs and supplies to come directly to their house with no human having touched it. So we call this zero touch delivery, such the whole time there's no chance of any infection. That would be great, right? How else might it help? Well, these vehicles can drive in a different way to humans. So if you don't have all the extra weight that is about having a driver, the steering wheel and the engine, and it's just really a box that is the right shape for delivery, your CO2 emissions are completely down. So the way in which you're moving these goods, I think, gets transformed as well. And we'll be able to have different vehicles of different sizes. So if you look at the van that brings your Amazon parcel or your home delivery, that van is huge, but probably your parcel is this big. So there's much more van than parcel, but we should maybe make the van the shape of the parcel, but we can't because you've got to sit a driver in it. So if you could remove all of the driver, all of that rubbish about having to go at 70, 80 miles an hour and just had the vehicle the right shape to carry parcels and delivery in your pandemic, then I think things are very different in terms of energy usage and the amount of parcels you can move.
Okay, then, well, my next question will be, okay, we don't have the cars right now, and this coronavirus is spread everywhere. So how this is affecting to the industry, to the development of autonomous vehicles? Is it accelerating development of them?
I think it is accelerating them. I mean, we had some time, didn't we, at Oxbotica, where we had the vehicles off the road because we couldn't be driving them, but we're back now. I think it's interesting for programmers. Certainly, we've seen a note that the development rate of the programming has gone up because the way in which we're working has changed. So there are less meetings, people are more productive. I think that's a small thing. I mean, don't get me wrong. I mean, having a COVID pandemic has changed the world and everything's slower and there's an economic downturn. It's obviously a bad thing. I think, though, that the case now for many vehicles, why you would want to be not vulnerable to not being able to have drivers, I think it's stronger than ever, right? So if you think about agriculture, if you think about the supply chain, you think about airports and ports, the ability maybe for humans to run the vehicles while not being in them is huge, right? And that's a really important point. So if you think about the mines in Australia, the people that are running some of the autonomy system are thousands of miles away from where the vehicles are. So there's still a human that's supervising, but just the human doesn't have to be sitting on a chair with a steering wheel in the vehicle. The human can else, and maybe that one human is now driving one. That's a very, very different thing. So it's not that we replace the drivers necessarily. It's that one driver could look after 30 vehicles.
I would like to move to the bit technical stuff and ask, like, how do autonomous vehicles work?
Yeah.
And what are the biggest challenges that we are facing right now with autonomous cars?
Okay. So, I mean, I could do a few minutes of some slides if you like, Thailand. Would that help?
Yeah, of course.
Yeah? All right, let's have a look. Yeah, that one. Okay, can you see that, Thailand? Yeah.
Yes, we can see it.
Okay, so I think if you want to build an autonomous vehicle, you need to answer these three questions: where am I? What's around me? And what happens next? okay? Because if you knew all of those perfectly, making a plan on how to move becomes really, really simple. So here's a simple architecture of how we think about the world in Oxbotica. We don't make sensors. You know, there are cameras and there are lasers and there are GPS, and they go in to a layer of software that has these questions. How do I move? What do I do? What's around me? And where am I? And to answer those questions, these software also have access to a map. And we can talk about how we build that map. That map, if you like, is just a memory of the world. So a vehicle is driven through the world, and it's got a list of memories of what that world looked like. So you might have that. So if you've, I don't know, have you ever been to Scotland?
Yes, yeah.
Okay, so did you go to Edinburgh?
Yes.
Okay, you can probably remember walking through Edinburgh.
Yeah,
You can probably remember walking down Princess Drive, I think it's called. That's a map. Right? It's not in meters, but you have a memory of what that place looks like. So you have a mental model now, and you can probably tell someone how to drive around the centre of Edinburgh. And so if you can build these maps, and you can build these maps using laser, or you can build it with radar, or you can build it with vision, you have a memory of the place. And when you run at runtime, you can take a picture and you can go, is this something I remember? So I've got a picture of that here, I think. Okay, so my mouse is frozen. 1 second. 1 second, just wait for my mouse to reconnect. There you go. Okay, so I'm going to show you this video. Now, this is the computer vision localizer running. So this is, I'm going to pause it here. Can you see my cursor moving around?
Yes, yes.
Yeah, okay. So what you're seeing here, this is the live image here. So that's an image coming in from the vehicle, a camera on the vehicle. And this is a memory, okay? These two pictures are different. So what the vehicle's doing is saying, well, hang on, look, I can recognize this and this. I can recognize the tops of this building, this and this. I remember that small bit of detail. And so what's happening here is the vehicle is using a real-time image, a memory of an environment, and then is using that to say, I know where I am inside my memory. And so we can do this with vision, or we can do it with laser. And here there is a laser map that is in white, and there is laser data that's coming here in yellow. And where there is something red here, it's because what I see now is not what I saw before. So something's changed. So the vehicles, it's saying here, I don't know what they are, but it knows where it is because it's looking at lots of that laser data in one go. Okay, so, and it gets quite hard, this localization, when you look at this. So this is the same route through Oxford in different weather conditions. And if I pause it, can you see that you as a human, if you look, you can see that this actually is the same place. Yeah, but look how it changes under different weather conditions. Mm-hmm. So one of the difficulties about using computer vision is how can I say that this picture here is the same as this picture here if this was the picture that was in my memory? And so we've done quite a lot of work on that. Let me ask, what can I talk to you about? So the maps that you can build can really be very nice. So this is a 3D map that was built by a and we've colored it in using pictures from a camera. As you can see, and we can then annotate those maps with where we have traffic lights, where there are roads. So now this map is representing not only the shape of the world, but actually what it means. So here we're saying there is a crossing here where people can cross traffic light. Okay, I won't talk about that. We can start to answer where we are in the world. The next step is, can you see what's around you? And so we use artificial intelligence and also some optimization theory to process images and figure out what is around us. So here, this code is taking a picture in and it's coloring in and drawing boxes around where it thinks there is a vehicle, and similarly for where it thinks there are people. So I know where I am now, and I know what kind of objects are around me. And of course I can do that in laser as well. So on the right hand side here, I'm taking laser light and I'm figuring out where vehicles are. So these vehicles here are these vehicles here, but this one on the right hand side, that's running from some laser. So if I pull those things together, I know what's around me, and I now have to make a prediction of what's going to happen in the future. So what you're seeing here is the car is sitting here, and these green things here, those are vehicles that the machine has seen using a scanning laser. And these paths here are where it thinks that vehicle is going to go in the future. So these are predictions of the vehicle into the future. So you can see our car wants to turn like this, but this vehicle is going to go in front of it. Now, if I'm lucky, I can move this thing around, and we're going to have, can you see here? Look at the bicycle. Can you see there's a purple bicycle?
Yes.
Yeah, there you go. That's what I want to show you. Here, it looks like the car could turn down here or go in front of us. So you have to predict the future with what we call multiple hypotheses. So, you know, it could go straight, or it could turn, or it could stop. And if we play this video forward, we'll see what it did. Here comes the car. What's it going to do? We think it's actually going to go straight on, and it does. Right, and then another cyclist comes up. Some cyclists come past us. We're waiting, and I don't know if we ever take off. Do we ever go? Yeah, and we drive. Eventually, we get to drive off. So this is the hard problem in self-driving vehicles, because I think we're very good at knowing where we are now, and I think we're very good at knowing what's around us. But this problem of predicting the future is really, really hard. And if you think you're in a city and you might have 20, 30 vehicles that you can see, and maybe 30, 40 people, you have to predict what they're going to be doing maybe 5, 6 seconds into the future, and that's very challenging. Does that explain?
Yes, yes. Thank you very much for the slides. I would like to ask another question, and actually we get some questions already. I will ask those questions as well. But first, back 5-10 years ago, a lot of companies were making predictions to have self-driving cars by 2020.
Yeah.
Then they realized that actually the problem was harder than they predicted, and even several big players have begun to walk back their predictions on how soon this technology. So my question, where exactly are we with self-driving cars at the moment? When to expect them to be part of our
Well, look, I think some of us always knew how hard it was going to be. There are some people who said, yeah, it'll be done in a few years. But I think the good teams knew that this was a really, really hard problem. And there's a difference between when the media say things and when the engineers say things. And I would also say one thing, though, as generally in technology, we always manage to overestimate in the short term and underestimate in the long term. It's a very common thing in technology that you go, oh yeah, it's going to be here and it's going to be amazing in 3 years. And then it's not 3 years. And then it happens a bit later, but you really underestimated how amazing it was going to be. I mean, mobile phones would be a really good example of that, right? So, 10, 15 years ago, it was like, oh, mobile phones are going to be amazing. 20 years ago, everyone's going to have a mobile phone and they're going to be incredible. And they did, but they were kind of big. But at that point, no one imagined that we would run our lives on a phone. Yeah, we thought it would just be for making phone calls. But now we run games, we run our calendars, we watch movies, they run our lives. So that's a really good example, I think, of overestimating how great it's going to be in the short term and underestimating its impact in the long term. I do think, though, that we will see autonomous vehicles appearing in cities and towns, but not for private use. It's not going to be that you can go and say, I'll have a car, please, for myself that has no steering wheel and no windows and it just has a bed in it, right? That's not happening anytime soon. It will be quite soon when you start to see vehicles running as autonomous shuttles, you know, around cities. So they're like micro buses. I think that will happen fairly soon.
And next question will be about testing cars.
Yeah.
So basically, what is the driver license test for self-driving cars?
It's a great question. So there isn't one yet. There isn't a legal driving test that they can take. In fact, still in law in many countries, you have to have a human in the vehicle, right, as a supervisor. So that's still true for a while. I think that's a really interesting. I don't think it's known how that's going to be. I mean, I think even the human driving. I mean, I tell you what, it's going to be a lot harder than a human driving test. A lot harder, because when you drive a human, you test the human for driving, you kind of think they've got human-like skills. So I think the testing regime that we'll put these vehicles through will be a lot harsher. But there isn't anything that's really sorted out for that yet. There is, though, certification and tests that can be done for autonomy in industrial environments. There are standards that you have to meet. For example, in mining, where there are autonomous vehicles driving around with no one in the cabs. So there are sort of construction and testing standards there, but just not in existence for the roads yet.
Okay, thank you for the answer. And my next question will be about some concerns related to self-driving cars.
Yeah.
Especially, well, these cars are collecting and broadcasting a lot of information, and they will be vulnerable to hacking. So, are we ready to meet these concerns?
That's another really good question. Look, I don't think there's anything special about hacking. Okay, I think so much of our lives is vulnerable, and they are software. Now, I'm saying that we have to be very, very, very careful about them. But as we do every system, as we do a phone, as we do a computer, as we do a bank account, as we do websites. So I think it's really important that as designers of AV technology, we really borrow and use the best in class encryption and security approaches that are used for all computer programs. I think it's bad to say, oh, we need to invent something special for cars. The technology we should use should be the same that keeps your money safe, the same that encrypts our conversations. And I think that's really important, such that you can get comfort that whatever the industry standard is for security on computers, the same is true of those vehicles. Now, that's not to say there aren't things that you can do with an AV that is different. For example, you know, will we need to introduce law that if someone goes to try and fool and confuse an autonomous vehicle, that's illegal? Because I can imagine someone thinking that's great fun, but I think that would be like causing an accident. Because if you know you can distract it, like it would be illegal to distract a driver on purpose to try and cause an accident. So what's the difference? And of course, it would be a stupid thing to do because the vehicle would be recording you doing it. So there'd be a lot of pictures of you doing this.
Actually, that was my next question. You already answered it. So I will move to another question. What about the car ownership in the future? Will we have more cars because everyone will be able to have a ride in it? Or is it
Yeah. In the short term, I don't think it will make much difference, because in the short term, these vehicles will, well, look, hang on, let's ask the question differently. Will there be more vehicles? I think so, yes. Because I think there'll be different kinds of vehicles. There'll be vehicles that do delivery. There'll be vehicles that run around hospitals, vehicles that run in airports, vehicles that run shuttles. Will we as humans ourselves own more cars because of it? Probably not. I mean, you know, the car ownership is changing in cities massively anyway, right? Depending on where you live, and they're expensive, and you know, in cities you don't use them very often if you own them, so that changes. But here's the thing: when have we ever, as a species, as a society, ever made something cheaper and better and then said, I want less of it? We always go, oh, I want more of that thing, right? So I think that if autonomous vehicles let us move people and goods in a different way, then we're absolutely going to want more of them. But that doesn't mean the roads are going to become clogged and worse, because I think they'll be able to drive differently.
So my next question will be from the comments. So Farhat Amirov asked such a question saying that, what about economic drawbacks of self-driving cars? Will there be
drawbacks? Yeah, so the obvious one that obviously people talk about is displacement of jobs, right? So, you know, drivers having different jobs. It's going to be a really, really, really long time before the impact of these vehicles on drivers makes a huge difference, because of the argument we're going to have more vehicles. Yeah, so we were always wanting to move more things. With just home delivery going through the roof anyway already, it's going to be a long time before we get, you know, delivery vehicles replacing those drivers. So I think that argument of it's not one or the other, but it's an additional two, is a very strong argument. But I think I accept the point here in that autonomous vehicle technology, like any technology, changes the workplace. If we're talking about something as fundamental as changing the way that people and goods move, then of course it's going to change some of the market and what jobs people do. The trick, and this is what governments have to do, is get behind that and say, okay, we need to change the skills and support the skills of people in a new world. And I think that's important. And with this one, we can see it coming, right? It's not like computers suddenly happen. We can see that for all time, we won't have humans driving all vehicles all the time. And so there are many cases where industries got changed. You know, for ports, for example, there are port managers in Australia who are now running the machines where they used to drive them, but there's still those jobs there. So jobs change.
We have a similar question from two people. One Rufat Azizov and Leila Jabbarzadeh, and they basically ask, could you tell us about accidents? Who is liable for a death caused by a self-driving car?
Yeah, it's not sorted out yet, right? So, but I would answer this question in the following way. We have law and an ability to figure out how to manage engineering difficulties when something doesn't work as we expected it to. So, for example, say, and what I'm saying here is that this AV software is just a tool, right? There's nothing particularly spooky or special about it. Yes, it's complicated, right? But you know, if a vehicle, if a tire blew out on a car, okay, that's a horrible thing. If all tires of that particular manufacturer all blew out, then we know what to do and what questions to ask of that business to say, what testing were you doing? Did you know about this? Did anyone decide to ignore it? There are lots of things that we have engineering process for introducing very complicated things like aircraft or jet engines into society. I think it's really important here that we understand that insurance is going to be the really, what I call the apex industry here. So insurers need to understand what autonomy is. They need to understand the upside for it and the downside for it. And there's a really interesting question here, because there will be accidents in self-driving vehicles, and they will be new kinds of accidents. They might well be accidents that a human would never ever have made that mistake, right? So it could be a thing that all humans would go, well, I wouldn't have done that. Okay, but that's because the intelligence that's driving the vehicle is inhuman intelligence. Okay, it's a different thing. It's not like you and I. It's different. It's got different skills. However, that same intelligence, although different to a human, might have stopped there being 50 accidents with that human previously. But is there any credit for that? How do we balance those upsides? That's a really interesting thing. Yeah, we don't normally have that. So you don't get any credit for reducing the accidents. So, you know, what would happen? Imagine accidents went down by, let's pick a number, 95%. That's an amazing thing for society, right? But the 5% of accidents that are remaining are because of a machine making things, making decisions that a human would not. What do we think about that? Is that something we want to have or not? And it's not for an engineer to say, right? It's for society, it's for the economy, it's for the insurers, and it's for the lawmakers to say. But that's a really interesting question, right? Imagine I could reduce, or we could reduce the accidents by 95%, but the remaining 5% were caused by machines not being human, doing silly things according to human reasoning, but hard by humans. What would we do?
Thank you for your very interesting answer. The next question is from Anwar Mohammed, and he says he asks that, do you think that the future of self-driving cars lie with increasing the amount of sensor inputs or improving ways we process it?
Both. I don't think it's an XOR. I think it's an and. Like, if this problem is so hard, I'll take and, not XOR. I do think there needs to be new kinds of sensors. I think radar gets quite good. I think there'll be new kinds of laser sensors and far better cameras as well. So I do think we'll get many more sensors. Computing will get better, but it's all of it, right? I mean, it's a robotic system. And yeah, I mean, you should think about a self-driving car as a robot. If you can get, you know, a better computer, better sensors, better knowledge and experience of how the world works, better memories, then it gets better.
The next question is from Habib Suleymanov, asking that how much computing power we need to process this information in real time.
Okay, so we use about, well, we're very unusual in Oxbotica, thanks to people like you, Tarlan, in that we use very little computation. So in the back of our boot, for the high speed stuff, which is up to 50 miles an hour at traffic coming at 50 miles an hour, we use a single chip Xeon to do that and a mid-range GPU. Other companies use huge amounts of GPU. We've been very restrictive on that because we want to get into the marketplace, and you won't be able to have 3 kilowatts of power. So we were running at 300 watts. I think it's a bit more than that now, but the perception, that runs on 30 watts.
Thank you. The next question is from Inglab Shahbazov, asking, are there lobbying efforts against self-driving cars' wide adoption by the industry because they can have devastating input on the employment and livelihoods of many drivers?
I haven't come across organized lobbying against it, and I think that's reasonable because vehicles that replace all drivers and change that is some time away. It's not imminent. It's not happening in cities. We will get these things in cities, and it will be a huge economic case. I mean, you know, the money that we made from shuttles is going to be huge, and mining, and absolutely. But I haven't come across an organized lobby against it. But there have been, this is something I can imagine might happen, and we will have to be sensitive and understand and listen to what that is. And as engineers, we must not go, never mind. We must be sensitive to that, and we must engage with policymakers, because like engineers want to make the world better, right? I mean, I started this not because I thought it would be fun, although luckily it is fantastic fun. I started it because I think the way in which we move people and goods is stupid. Like we have accidents, we hurt each other, and we pollute. There are just, our energy usage, our CO2 emissions, we clog the roads, and the accidents we have, and worse than that, we don't let our most vulnerable and needy people have access to transport. Yeah, so like my father, when his eyesight started to go, he wasn't able to drive. That's the time that he wanted to drive the most, was to see friends and family, and yet when we're most vulnerable, we don't do it. So I think that there are good reasons for wanting to do this, but that's not to say that engineers shouldn't really listen to social scientists and economists and messaging about how to make us not force this technology on people, to say this technology helps. It's in addition to what we do already, and not to replace it. I feel really quite strongly about that, actually. I think engineers want to fix stuff, right? Engineers are forever fixing the broken thing. And I think, without doubt, transport is broken, right? I mean, transport's derived from someone who had a horse, where we, on ponies. And if you look at the whole thing, it's all derived from, motorized horses. We wouldn't do it like that now if we started again.
Thank you. And the next question is from Sevda Aydın, and she's asking about trolley problem. How will cars make moral decisions if humans' own moral decision-making ability is not yet fully determined? Based on what cars will make decisions?
Okay, so what was the question there? That was the trolley problem question, right? How does a car make an ethical decision? Okay. Thanks for asking that question. I always like that one to come up. Right. I'm not going to tell this audience what a car must do in a moral situation, right? What I am going to say is, here are the ways in which society could choose to have this question answered, because engineers can offer multiple solutions on how to do it. So normally what I do is I get people to stick their hand up if they like, if they would choose that thing. So one thing you could do, so there's a vehicle, and I'm going to set a scenario. There's a vehicle going down a road, and there are two vans either side of the vehicle, and two people come out behind those vans. Okay, so they weren't seen. Okay, now this is not a fault of the vehicle. Okay, I'm setting this problem up as a physics problem, right? So two humans have suddenly appeared in view of the vehicle, and the vehicle has enough speed and mass that it can't get rid of that energy in time. Really sadly, someone's going to get hit, not because of a fault of the vehicle, but because of Newton, right? Because of how the universe works. Okay, right. So we've now our computer program in our vehicle has to do something. So we've got some options, and society can choose how this works. One option is randomly choose person on left and person on right. Heads or tails, okay? You may or may not, I don't have a view, and I wouldn't propose to have a view. You could just say it's a random thing, okay? You could say, let's behave like a human would in this situation. Because it turns out that most humans faced with that situation, well, some humans don't steer, they just brake. Yeah, they just slow the car down as possible, kind of in the direction it's going, and hope for the best. You might decide to do that. But what if the vehicle could see the height of that person? And the person on the left was 4 feet high, and the person on the right was 6. Right. What should we do now? Should we drive as a human and try not to panic? Should we go heads or tails? Or should we go, statistically, people that are taller come out better in accidents than people that do worse? It's a horrible situation, but maybe you should say, actually, the maximum to minimize the maximum human damage, I should look at those numbers, and we've done this by counting in accidents because we know. Okay, so that's a possibility as well. So, but this is a really interesting case that I've introduced here, because a human at that rate may not be able to make those decisions. Yeah, so a human faced with that might not be able to go, I should probably do this because mathematically it's the coolest thing to do. Now, we may decide that we don't want that to happen at all. We may decide as a society that we still want it heads or tails, or we might want it to choose randomly between those three possibilities: heads or tails, go in a straight line, be like a human, or be superhuman and try and do the thing that does the least damage. I know which one I would like them to do. But I'll finish this question just by asking one question. I've done these sort of talks for 10 years now in audiences, and it's really great to get this question. I've never ever met anyone who has met someone who ever says, this one time I was driving my car and two people came out in front of me and I chose the person on the left because, and then they finish the sentence. It's a no-win situation that was made by philosophers. Now, I'm not saying we should engage in it, but it's a terrible situation. A terrible thing is going to happen. There isn't a good answer, but also it's not a problem that I've seen humans or known any humans have to solve. And I'd be very happy to hear if someone said, yes, I do remember being in this situation where I made a moral decision of the same construct as the trolley problem. I think it's extremely rare. And even if it does exist, it's very rare. The upside of having these vehicles cause less accidents is so huge. I don't think we should get distorted by it.
Yep. Thank you very much.
That's an honest answer from me.
Yeah, it was very great. The next question from Habib Suleymanov again, asking, processing industries are using different level of redundancy, reliability to mitigate the risks of accidents, and asking, are you developing tools for safety reviews? Do you also design and build independent automation control systems to take into account for failure in one of your systems?
Yes, so I mean, one way to think about this is you need to have redundant and independent routes through the system. So redundant routes are, for example, I might have 7 cameras and I might have 3 lasers. So each of those cameras is redundant because there are 7 of them. But the lasers and the cameras, they're independent sensors of each other because they work in a different way. So you would typically have a camera, a laser, and a radar all working at once, and they're offering independent sensing and redundant sensing because there are many of the same type. And that carries on to when you look inside the structure of the software, that you will try and have multiple routes for signals to throw through the system that allow, for example, one of the AIs to just not see that it's a person. But something else has to say, well, I don't know that it is of kind person, but I sure know there's something there and it's moving. So you have these systems that fall back. And so you don't expect the AI system to be working all the time. You don't expect any part of it to be working all the time. There is there is one point though, where you have to make a decision, because and it gets interesting. You can have all of these independent systems going through, but at some point there is only one control signal that you can send to the car. You have to decide. So you can have all of this complicated stuff upstream about multiple hypotheses, redundant routes, but in the end of the day, you have to boil the thing down to one world model where you say, I think this is going to happen and I'm going to make a decision. And it's interesting to think about that when you're a learner driver is one of the most scary things. Because when you sit, do you remember when you were learning to drive, you're sitting at a roundabout and you have to go. You can't half go. Yeah, if you half go, everyone shouts at you because it's really dangerous, because everyone thought you were actually going to go for it. And I find that quite interesting, that you have all these independent routes in software, But at the end of the day, the software has to say, do this. And it has to be one thing. Now, you can then have independent hardware that's checking that that signal is not going to get corrupted, and independent power supplies. But at the end of the day, the software has to send one action. And I find that a really interesting robotics problem.
I'm moving to the next question from Nazreen Mushtaqzadeh, and she's asking, as driving becomes a murkier concept requiring less and less from individual engaged in it, at what point would an intoxicated or unconscious person no longer be guilty of a DUI or falling asleep at the wheel?
I don't know. I don't know. I've thought about that. I don't know the answer to that question. I mean, it could only be in a vehicle that we would call L5, which is no steering wheel, no control surfaces whatsoever. I don't think the law's thought about this. I was talking to someone the other day that was talking about, you know, legal issues in autonomous vehicles, and they were saying there's a lot of law about horses. This is really interesting, because if you're in charge of a horse, there's law from 200 years ago about what you can and cannot be held responsible for if you're riding a horse in a city or a town and the horse does something stupid. And that's really interesting, right? Because the horse also is an intelligence, right? It can miss stuff. It can make predictions. It kind of knows where it is, you know, so that's not a bad model of an autonomous vehicle. But there's a human on top of it that's not doing the walking and can be looking around, but in some way has some responsibility. So I found that a really interesting analogy of where you can find law about responsibility for something that is inhuman, but kind of a mobility system, although it's a furry mobility system.
I want to move to the next question asked by Farid Aliyev. In your opinion, what kind of new jobs, professions, and new skills could appear with autonomous vehicles?
Well, so many. So the simple one is jobs like yours. Mm-hmm. So autonomy engineers. There's going to be loads of them, and you know, I think robotics is going to explode. I mean, it will be like 30 years ago there weren't programmers. Well, there were, but you know, 40 years ago there weren't programmers like they are now. It's a whole new profession. So I foresee a whole new profession for robotics and autonomy coming through. Some people programming the raw parts, some of it using it. So for example, I can go to a port in Australia and find some stevedores. They're the people that run the ports and look after the wharfs, running autonomy systems. So they're responsible for running the autonomy system. There are jobs in Australia where, and this is great for return to work mums after having a kid, are running mines, because the mines are up in the north of Australia, but they're running them down in Perth remotely. So I think for every vehicle that you have, or every kind of vehicle that you have, there will be jobs maintaining, programming, making, or indeed using it.
Oh, thank you very much. And my next question, okay, the next question from Rufat Azizov, and he's asking about autonomous vehicle is based on artificial intelligence technologies. So how AVs are going to avoid unfair biases within AI data flow?
That's really interesting. Well, part of the answer for that, I think, is sort of a checker. I think we will definitely have, of course we will, AI is having a really important part of it. Part of our architecture is to say that there has to be a route through that is not using AI that can check. Yeah, and it may not have such a rich picture of the world. It may not be able to say, that is Tarlan's face and he's carrying a bag and he's going to cross the road, but it can see that you're there. And the fundamental job of the vehicle is to not hit people and get you from A to B, right? And I think that can be done crudely, and you can have something checking it as well. But I think I think AI bias, you know, it turns up. We're having a really big conversation about this yesterday, actually, because one of the things we've just published and you've been working on is the deep fake stuff as well. So how can we generate synthetic data such that we don't have to label many images in the AI? So how can the AI itself produce something to teach an AI? And you can imagine there's a route in there where you could get some bias if you're not careful. So you've got to watch out. It's a hard and I think unsolved problem, and one that we must watch, like we do for bias in all walks of life. Of course, you know, we've got to be careful about our interactions with other humans. Not surprising, then we've got to be careful in bias in the things that we make.
I will have probably last 3-4 questions, and the next question is. Different companies, especially these automobile companies, they are taking different approaches when it comes to how to go through the levels of autonomy. Is it just directly to go to level 5 or just go step by step? And like, so, for example, like Tesla's, where they put some kind of features, but not autonomous. Which one of them is more preferable or easy, or like, also which one of them is ethical?
I think my answer to it is that, you know, you can build a system that asks you to drive less, but you're always going to be in charge, right? That's, you know, so, or you can say, actually, we're going to remove the driver completely, so there is no control surfaces available at all, but we will run that vehicle in a very limited place. So we'll run it in a geo-fenced place, that's called. So the vehicle only goes on certain roads because it's practiced, and you can say something convincing about the performance of the vehicle on those roads because it's been rehearsed, it's been simulated, and it's not trying to go everywhere. So if the conditions are dangerous and the vehicle goes, there's just too much rain, the lighting is too confusing, it's too harsh, there's not enough lights, then it says, I'm going to stop. Because, and that's called ODD, because then it's out of the design domain. So if the vehicle will then say, right, you know what, I can't operate in these conditions, I'm sorry, I'm just not operating as a bus, then I think you can get level 5 first.
My question will be actually something about related to Oxbotica. And at the beginning of your talk, you mentioned about using the technology in mines, ports, airports. I can see the universal autonomy written under the logo. So what universal autonomy means?
Okay, so for us, this was, I see the problem, and I've been working on this like for what, 25 years now. I see the problem of where am I, what's around me, what should I do, as universal problems for autonomy. It's the same problem if you're in a car or if you're in a port, if you're in an airport. You need to do the same things. And so what Oxbotica built was a software platform that can work in many places. It doesn't need any GPS. It can work indoors or outdoors or underground. So, you know, we're excited about that. And then what we will do is we will commercialize it in different orders. So we go for mining first, we then go for shuttles. But for us, it's the same software problem. Yes, there is definitely some specialization that needs to happen on the commercialization, but the generic problem was universal autonomy.
Thank you. And we have 2 more questions from Facebook. Self-Driving asking that newer vehicles may record data on how, when, and where individuals drive.
Yeah.
Could raise privacy concerns if the information is stolen or improperly.
Yes. Yes. Yes, and there are many privacy issues here. I think, though, again, I would come back to the privacy issues that we have with our phones and our computers and our banking and all those things and our internet use. There's nothing special about autonomous vehicles in those concerns. And I think it's really important as an industry, again, we look to other industries to say we are not alone. This is not a special problem that belongs to us. Like the internal combustion engine was kind of a special problem that belonged to cars and gearboxes. You know, that's a huge amount of effort, and it was kind of owned by them. But computing is not owned by autonomous vehicles. So I think that's a really important thing that we must keep pushing. Like, let's not invent our own security. Let's use the best in case security in computing, full stop.
The next question from Anwar Mohammed asking that how hard is it to get more training data? Is it a very big challenge?
Well, you know about that. Yeah, it is hard. And again, this is why we're interested. In fact, we just gave a talk, didn't we, at CVPR on how we can generate and access large amounts of training data that scales beyond humans sitting and drawing in pictures. So one of them is simulation, one of them is deep fakes, and one of them is transferring labels, for example, from something in laser to seeing it in cameras. So you might, and you could talk about this, but you might build a model of this world in laser, and then you might mark in virtual land where the edges of the road are or where a building is. And then every time you drive in a picture, you can project that into the picture, and that gives you training data. So, I mean, I wouldn't say there's one way to do it. I'd say like 30 tricks that you must pull, and I'm probably missing another 90. Like, this is going to be the problem on how to do this.
And my final question will be about Azerbaijan. So, because we have Azerbaijan Association, so this technology, like developing self-driving cars, obviously requires a lot of investment, and we can expect like countries, USA, UK, Germany, they invest to this technology. But how other countries, like developing countries like Azerbaijan, how should we?
I think that's a great. I feel really strongly about this. It isn't expensive to program, right? Don't need to be building things out of metal, and you don't need huge factories. Programming and software has no mass. It amplifies beyond imagination, right? So when you made your first copy, making 1 million copies takes you no more money. Get the right team of software engineers together, and they can do more than a team of 500. Yeah, it's about how you program, what you program, how well you do it, and how much fun you have in doing it. So I think that's what's so wonderfully democratic about software is, yeah, there's difficulties with testing, but that can be sorted out with partnerships and who you go to market with. And if you want to build the whole thing, I will do a new car, the new sensors and the software, and I will run that fleet by myself, then that is incredibly expensive. But if you want to write software that does this, then you don't need huge teams, because software has no mass and it has no inertia, and it scales brilliantly. So you absolutely can, and you absolutely should. This can be owned by everybody. There you go.
Thank you very much for your time, for your answers. It was an honor to have you here with us. I'm hoping that next time we can do this in Azerbaijan and we can host you there after pandemic.
Yeah, that would be awesome. That would be awesome.
So,
Taran and everybody, anyone or anybody that's watching, it was a pleasure, and stay healthy and stay safe.
Thank you very much.
Bye. Bye-bye.